Hello students, welcome to Sarasa classes. This is Dr. Sarkar over here. Today we are going to discuss DL configuration in the carbohydrates and a few more things about the carbohydrates. If there is any easy technique to remember the structure of type carbohydrates. So for that, let me begin by saying that we are discussing over here the aldoses. So when I have written CHO followed by a C and then followed by a CH2OH. When I write the OH group on the right hand side and the H on the left hand side, because I have written the OH group on the right hand side, it is called as D. Common name is glyceraldehyde. Since the carbon chain is having three carbons, it is called a aldo triose. So what should be the L glyceraldehyde? That can be simply written as CHO. Now OH group has to be placed on the left hand side, followed by the rest of the groups. Then this can be named as L glyceraldehyde. A shorthand way of representing D and L glyceraldehyde is to represent the CHO group by a circle, the carbon chain by a vertical line, just like that, and the OH group can be represented by a horizontal line coming from the vertical line. So if this is the D-glyceraldehyde, the structure for the L-glyceraldehyde will just be a mirror image of the D-glyceraldehyde, wherein the OH group has to be placed on the left hand side coming out from the vertical line. Okay, now so this is over here, we will say carbon 1, that is carbon 2, and that is carbon 3. As simple as that. Okay, so this is basically a shorthand representation of a aldotriose. Now if you want to go from this aldotriose to aldotetroses, okay, how one can do it? So what I am going to do is I will again draw a circle to represent the CHO. So that is carbon number 1, and I should have a horizontal line, but there should be two of them. So this is the horizontal line indicating that this is a D, okay, sugar. And if I write another horizontal line, okay, I can place it on the right hand side or either on the left hand side. So if I place it on the right hand side, this molecule will be called as D erythrose. Similarly, using the D glyceraldehyde shorthand notation, I can write the other sugar wherein the penultimate carbon will be having the OH group on the right hand side, but the OH group just above will be in the left hand side. So this molecule is called the threose. Okay. Now the mirror image For D-erythrose will give you L-erythrose, okay, just like that. So you can have the OH group in the left hand side and also the other OH group on the left hand side. So this is your L-erythrose. What should be your D L threose? Then for that you will write just the mirror image of this molecule is what? That one, and the group is like that. So this is called your L threose. Now, if you look carefully, aldotetroses have two such stereogenic center, and the molecule is asymmetric. Okay, so what we will say for such a molecule, number of optical isomers, formula is 2 to the power n, number of stereogenic centers, which is n, we can see it is 2, so 2 to the power 2, and total we are getting 4 such optical isomers. Okay, now if we want to go from the aldo tetrose to aldo pentoses, again we have to increase one more horizontal line on the top, just like coming from here, like that. So let's use D-erythrose and see what molecules can be produced from it. So here we have D-erythrose like this. Now one more line. That means we are now from here we are having 5 such carbons. So 1, 2, 3, 4 and 5. So this is the Aldol Pentos. So one possibility is this. What is the other possibility? This is the CHO group. Like that, it is D-erythrose. Now if you write the other OH group on the left hand side, okay. So from D-erythrose, increasing one group over here and one OH group over here, we can produce two different aldopentoses starting from aldotetrose. Now let's check the D-threose. So this is your, to begin with, a D-threose like that and like that. If you put one OH group over here, this is one possibility of aldopentose. What is the other one? Like that you have, okay, put the OH group on the left hand side. So now one can say from the erythrose we are getting these two molecules, and from the threose we are getting these two molecules. Okay, the best way of remembering this is to remember this mnemonic, which is called as ribs are xylophone like, where ribs means this is called as D-ribose, sorry, D-ribose, that is ribs means ribose, this is called D-arabinose, this is your D-xylose, and that is your D-lyxose. Okay, so that is one short method of remembering your aldopentoses. So from aldopentoses, now one can go to the aldohexoses, just the method that we have been doing. So we will use the ribose to build the next two hexoses. So this is your ribose, one OH group. If you add, okay, so this becomes a 6 carbon molecule, and this is called D-allose. Again, you use the ribose, just like that. 1, 2, 3, but the next one will be on the left hand side. This is called the aldehyde. Okay, so these two allose and aldehydes are coming from D-ribose, one can think of. Now let's draw the other hexoses. So now we are going to use which one? Arabinose. So let's draw 1, 2, 3. Okay, if I place it, sorry, it is 1, 2, 3. So this is my arabinose, just check. Okay, now you place the OH group on the right hand side, you get one of the hexoses. Similarly, 1, okay, 2, this side, then you place another one that side. So the first molecule is nothing but your glucose, and the second one is called D-mannose. Okay. If you use the D-xylose, what other sugars can you make out of it? Let's have a look. So xylose meant something like, yeah, that one. So you place on the right hand side one group like that. Again, two molecules will come out of it. Place on the left hand side. Okay, and the last one is lyxose. So we will get again two more such hexoses from the lyxose unit, like that. What was lyxose? Yeah, like this. So it is that one, and the next OH group will be on the right hand side, like that, like that, like this. Okay, so the mnemonic to remember all these 8 hexoses is what? All altruists gladly make gum in gallon tank. So all stands for allose, altruist stands for altrose, gladly stands for glucose, make stands for mannose, gum stands for D-glucose, in stands for D-iodose, gallon stands for D-galactose, tank stands for D-tyrosine, talose. So that is the way one can, without mugging up the structures, produce all the structures of the carbohydrates, that is the aldo triose, aldo tetrose, aldo pentos, and aldohexoses correctly, even if he wants to do it in an examination hall. Okay, just some practice and you can reproduce the whole thing in 2 to 3 minutes. Thanks for listening. Keep visiting Sarasa classes for much more such unique techniques, okay, to learn harder concepts. Thanks. Have a great day.